So before we dive into example number 2, we need to look at two theorems. One theorem is the angles inside the circle theorem. That's really what the textbook calls it. The angles inside the circle theorem. So if you have a perfectly drawn circle like this, and some intersecting chords, and we'll label this A and B, and then we'll label this D and C, and this would be angle 1 and angle 2. BD is the line that 1 and 2 share, so they are a linear pair, so that means that the measure of angle 1 plus the measure of angle 2 should add up to 180 degrees. That's kind of important. And then from some of our previous information, what we know and we can derive is that the measure of angle 1 is equal to 1/2 times the measure of arc DC plus the measure of arc AB. Okay, and then the measure of angle 2 is equal to 1/2 times the measure of AD, A to D, plus the measure of BC, the arcs. So, and then again, if I add these two up, because these two equal 180, then these two would equal 180. And let's see what that's the one theorem, so just kind of hold on to that. That's one theorem. Then the other theorem is, it's called the angles outside. And this is referring to circles. And so there's like three scenarios. One is if I have a circle that looks like this, and I have a line that goes through the circle, that intersects the circle, and then has a tangent. So this is a point of tangency, this is C. Okay. And so we'll label this point here A, this point here B, and then we'll call this the measure of angle 1. Well, for this particular scenario, we say that the measure of angle 1 is equal to 1/2 times the measure of arc BC minus the measure of arc AC. And so in our example, we'll go through there, and we'll, oops, sorry, you couldn't see that, I'm sorry. So when you have a line, so here we have an angle, and this line, or ray I should say more properly, this ray here intersects the circle at 2 points, and this one intersects at 1 point, so that's a point of tangency. So C is the point of tangency. Well, when we have the scenario, the measure of angle 1 is equal to 1/2 times the difference between BC, the arc of BC, minus the measure of A to C. Okay. Now, if we have, there's three scenarios here total. So if I have another scenario that looks like this, and I have a point of tangency here, and a point of tangency here, right? And we'll label this Q, R, and P, and then the measure of angle 2. So then this, if your scenario looks like this is the measure of angle 2, and that's equal to 1/2 times the quantity, the measure of arc PRQ, or PQR, I'm sorry, minus the measure of PR. Okay? And that's it. I mean, we can prove that. But I don't. Sometimes when I do the proofs for these, it kind of bogs you guys down. If you, basically, I'm going to draw three particular formulas, and what you're going to do is you're going to take these notes and you're going to look at these notes when you go to do the problems today, and you're going to say, does it look like this? Then you use this formula. Does it look like this? Then you're going to use this formula. And then the third scenario is this. You have a perfectly drawn circle, and you have an angle of 2 rays, and it intersects in 4 spots. So we'll call this W, we'll call this X, we'll call this Y, and we'll call this Z, and then we'll call this angle 3. So then in this scenario, the measure of angle 3 is equal to 1/2 times the measure of the arc XY, oops, not yet, minus the measure of WZ, the arcs. Okay? And so what you're going to do when you do your homework, you might have a problem that looks like this, use this formula. You might have a problem that looks like this, then you use this formula. You might have a problem that looks like this, use this formula. So here we have 3 intersections. Here we have, let's write that down too, 3 intersections. Here you only have 2 intersections. And here you have 4 intersections. So another way to do this too is, like, when you look at it, just ask yourself, how many times does the angle intersect the circle? Here it only intersects 3 times. Like 1, 2, 3. Here it intersects 2 times, 1, 2. And here it intersects 1, 2, 3, 4 times. And so based on the number of intersections of the angle, you know, how many times does the angle intersect the circle, then you could choose the appropriate formula. Okay, so we said all that just so we could do this next problem. So I'm going to do example number 2 eventually. And it's 2 parts. So I have the first part is I have 2 chords that intersect. We'll call this x degrees. We don't know what the measure of that angle is, and this is 130 degrees. And we'll call this J, L, M, K. Now, the way that we do this is oh, I forgot to write this. This is 156. This angle, the relationship for this is going to be x degrees is equal to 1/2 times the quantity, the measure of JM, the arc J from J to M from here to here, plus the measure of KL, or LK. And I just pulled that from here, right? So this is our notes. Okay, and if I look at that, this is like measure 2 in the notes, right? And measure 2 is AD, the top half, BC, the bottom half. Now, it's real easy for Mr. Adams to do that off the top of his head. I should be able to do it. I'm a math teacher. I wouldn't be a very good math teacher if I couldn't do it off the top of my head, but you're just learning it. This is why it's so important to write your notes down. It's literally just a basic math problem if you just look at the formula. In this scenario, I see that this angle here is equal to the average of this arc plus this arc. So then I just apply that to this. This angle here is the average, 1/2 times this plus this. So let's plug that in. X is equal to 1/2, and then we've got 130 plus 156. And if you plug that in the calculator all in one swoop, X is equal to 143. Okay? And that's it. That's it for that part of the example number 2. Now there's another part of example number 2 that we have to do where it looks like this. I have a perfectly drawn circle. I have a tangent line that intersects here. We'll call this point C. We'll call this point D. And then it intersects twice. We'll call this B. And we'll call this A. And we're told that this arc from here to here is 76. And then this arc, this big arc here, that's a 178. And then we call this X. So we're asked to find X. Well, again, remember that the measure of BCD, because that's what X is equal to something. So I got to look at this. As I look at this, I got to make a determination which formula to use. I notice that it intersects here, here, and here. So there's 3 intersections. Okay? So then all I got to do is I got to look at my notes and look at a scenario where there's 3 intersections. So this is the scenario where there's 3 intersections. So then the formula is going to be this formula here, right? My angle here is going to be equal to 1/2 minus the big arc minus the little arc. So to translate that to here, that's going to be equal to 1/2 times the quantity of the big arc, which is the measure of AD, minus this little arc, which is the measure of arc BD. Okay? So then that would mean that X is equal to, X degrees is equal to 1/2 times the quantity, 178 minus 76. And so X then would equal 51. And that's basically it.